Hello everyone, welcome to the world of math. In this video, I will show you how to solve quadratic equations by using square root property. In solving quadratic equations, there are two values that can be obtained, and these values are the solution of the equation, which is also called the roots of the quadratic equation. And one of the simplest methods in determining the roots of the quadratic equation is by using the square root property. And here's the general rule for square root property. It states that if x squared is equal to a and a is greater than or equal to 0, then x is equal to the positive and negative square root of a. So in the form of a square root property, we have here x squared equals a, wherein x squared is the quadratic term and a is the constant term. And the value of a should be greater than or equal to 0. So we'll get the root of real number. Because if the value of a is less than 0 or negative, the result will be imaginary roots. And by getting the square root of both sides of the equation, we'll get x equals positive and negative square root of a. So how did we get that part? Remember that radicals are the equivalent form of rational exponents or the fractional exponents. So the square root of x squared is same as x squared quantity raised to 1/2. And if you can still remember the laws of exponent, we can use the power rule in this expression. So 2 times 1/2, it will be x raised to 1. And x raised to 1 is same as x. And notice that the value of the number or the solution has a symbol of positive and negative, which indicates that the two resulted values for x are the positive and the negative square root of a. And remember, the square root property is only applicable if the given quadratic equations have no linear term. Just like in the form x squared equals a. Or we can also use this if the given equation is transformed into square of binomial. And in solving quadratic equation by using square root property, it is also important to recall the perfect square numbers so we can easily get the square root of a number. For example, we have here 1 squared or 1 times 1 equals 1. The square root of 1 is 1. Or we can just say, since we have the positive and negative root of a number, we have square root of 1 equals positive and negative 1. And then 2 squared is 4. So the square root of 4 is 2. And we can also use negative 2. Okay, so we need to familiarize ourselves in these perfect square numbers. Okay, so let's have an example. X squared minus 36 equals 0. So the first step in solving quadratic equation by using the square root property is we need to isolate the squared variable or the expression using the properties of equality. So meaning if we will isolate this, we need to transpose negative 36 to the other side. And it will be positive 36. So we have x squared equals 36. The next step is we will apply the square root property by getting the square root of both sides of the equation. So square root of x squared equals square root of 36. Again, the square root of x squared, we can cancel the radical sign and the exponent too, and that is x equals square root of 36. So that is 6, but we need the positive and negative value. So x is equal to positive and negative 6. I will give you another example. Let's say we have here 3x squared equals 27. Again, in the form of square root property, the numerical coefficient of the quadratic term should be 1. So we need to eliminate 3 in this equation by dividing both sides by 3. So 3x squared divided by 3, that is 1x squared, or we can cancel this, and the remaining one here is x squared, equals 27 divided by 3. It will give us positive 9. And then since we already isolate the squared variable here, we will apply the square root property by getting the square root on both sides. So the square root of x squared, cancel this, we'll get x equals the square root of 9, that is positive and negative 3. Therefore, the value of x in the equation 3x squared equals 27 are positive and negative 3. Let's try another example. Solve for the variable of the following quadratic equation. For number 1, we have here x squared plus 14 equals 50. So in this equation, we'll need to transpose 14 to the other side. And it will lead us to x squared equals 50 minus 14. Simplify it. 50 minus 14, that is 36. So x squared equals 36. And then after that, apply the square root property. Square root of x squared is x equals square root of 36 is positive and negative 6. Therefore, the values of x for this equation are positive 6 and negative 6. How about in number 2? We have the given equation of 3 times the quantity of x plus 2, quantity squared, minus 11 equals 64. So the first step again here is to isolate the squared variable or expression. So the squared expression here is 3 times the quantity of x plus 2 squared. So we need to transpose negative 11 to the other side. And we have 3 times x plus 2 quantity squared equals 64 plus 11. We can simplify this. 64 plus 11 is 75. So we have 3 times the quantity of x plus 2 quantity squared equals 75. Just like in our previous example, we should eliminate the numerical coefficient in this part. So to eliminate this, we need to divide the equation by 3. So cancel this, it is equivalent to 1. And 1 times x plus 2 quantity squared, that is x plus 2 quantity squared equals 75 divided by 3, that is 25. And then, to remove the exponent 2, we need to apply the square root property. So square root of x plus 2 quantity squared, cancel this, we'll get x plus 2 equals square root of 25 is positive and negative 5. And then, to solve for x, we need to transpose positive 2 to the other side. So we have here x equals negative 2 plus minus 5. Since we have here two signs, or we have the positive and negative value of 5, we need to separate the solution. Okay, so for x sub 1, we have negative 2 plus 5, and that is equal to positive 3. And then for the other solution, x sub 2 is equal to negative 2, then and then minus 5. X sub 2 is equal to negative 2 minus 5. The result here is negative 7. Therefore, the values of x are positive 3 and negative 7. And that's all for this video. I hope you learned something from me. Thank you and God bless.